Well, folks, we've got another one today. Same batch. This time it's an Amstrad 901. And before you all switch off, there's something special about this one. It's not only the made in Japan one with the original early type of power connector, it's the one which actually has a power lead. I think Noxyman ought to scan one of these and make one on his 3D printer. But there we are, got the proper power connector. And considering you couldn't get those power connectors even a year later, that's like rocking horse, what's it? So it's got some very wrong brackets which we've got to try and keep track of. It's come with a standard replacement microphone, because this is the set that came with the Action Man mic. And the Action Man mic was not very robust. So I'm going to whip the screws out, but I'm not going to... Oh, they're not supposed to be... Oh no, I was going to say, I thought I was a self-tapper there. We'll take some measurements before I open it up. So what I like about the Amstrad 900 as opposed to 901 is that they're always going to be the made in Japan genuine versions. There aren't any dodgy ones or cheaper ones. They're always going to be this version, so they always work well. So we've got a mic there which is come with, that's standard replacement mic, but we'll use our standard replacement mic for all the setup and the tests. Right, we'll get that connected to our power supply. I said before, I think there's a Comtron CB40F in this batch of sets, and I think there's only one set left, so I deduce that might well be the next set. So 9 volts, I've got the power supply on, 300 milliamps current limit, and I haven't switched the power supply off standby. There we go. Pop it on channel 20, and we'll now turn the power supply to 13.8 volts. By the way, it's drawing 125 milliamps at this point. There we are, now it's drawing 205 milliamps. I wonder if we can find another corner of paper. I'm trying to keep them all on this same little sheet. Yeah, I think we can just cram it down here. Amstrad CB901. Right, I'll switch picture in picture on. Press transmit. I'll put it on the 3-watt range. It's doing more than 3 watts. It's doing 3.4 watts. Deviation, wallow. Point 8. Frequency. Not illegally low. Hopefully that'll pull up somewhere nearer. I do find some of the crystals have aged beyond coming up to full frequency these days. I'm sure that'll come up a bit more. Right, now we'll set the signal generator to the same frequency it's transmitting on, so it's a fair test. we say 096. That'll do. Let's go over to the cyanide meter and see what we've got. It will also help if I plug in the cyanide meter. Oh, so I hope if I can see which socket is which. Let's try that one. Or is that PA? Let's switch to PA. Testing 1, 2. Why can't I suddenly hear anything? Just plug the PA speaker in, which is mounted on the wall. Testing 1, 2. No, it isn't that one. Testing 1, 2. Testing 1, 2. Testing 1, 2. 1, 2, 1, 2, 1, 2. Testing 1, 2. 1, 2, 1, 2. We've got a dirty volume control. We've got a dirty PA switch. No wonder I'm not getting anywhere. Right, the squelch is set up wrongly. That's another reason. So I've got 3 reasons why I couldn't hear anything. The PA switch is dirty, the volume control is dirty, and the squelch is on all the time when there's no aerial plugged in and no signal. Right, so having... And the squelch is still too low. Tell you what though, that's not bad. It's 0.3 of a microvolt. It's very good, in fact. There's quite a lot of things need sorting on that, on receive. 0.3 microvolts for 12 dB cyanide. Right, we'll whip the lids off. I'm going to try and keep the top lid on. I don't like it when it's that type of dropper resistor. I know this is how it was. I think they were bulk modified in the UK, but it's only like a 3-watt resistor, so you can't be expecting it to source that much. Anyway, let's have a look. I'm tempted to get the service oil on that right away because it's going to be annoying throughout this if we don't clean it. And whilst I'm at it, they're probably dirty as well. Can I get to that lower one? I think so. Right, so we need to start by doing the VCO. And this, out of all the different chassis around, is probably one of the most important to set the VCO on. Or you're going to end up with channels dropping out. So if I can see if I can find the appropriate service manual without having to dig deep. There we go. So we know it's transformer 1, which is there, coupled with the capacitor there. So channel 1 they have you do it on these. So we're on channel 1. It's between capacitor 9 and you want 12 volts. Borrowing Mr. Chippy's crocodile clip lead, I think this is a negative earth chassis, but we'll just check. Yes, it is. So capacitor 9 is the far end of that. And at the moment it's 2 volts. 2.09 it should be. So let's get that in shot. 2.09 it is. I don't need to touch that, that's spot on. So going into transmit, should stay at 2 volts. It's 3.2, that needs to be altered. So it's 2 volts on receive. I've got 2.2 on transmit. So let's just see whether that works out at the other end. So we need to go to channel 40 and check it's between 4 and 5 volts. So we're on receive. It's 3.56 and on transmit it's 3.38. Now I'm happy that that's in lock. You've got to take this with a pinch of salt. And you're not quite sure what test instrument they use to do the measurement, because it's very often that you're not going to get the range which they say. I'm happy that's in lock. What you don't want is it to be like 2 volts when you're on channel 40, and conversely you don't want it to be like 5 volts when it's on channel 40. So you kind of got to use your nozzle there. I mean, for all I know, you did it on an AVO 8, but they just didn't say in the manual. The manual isn't that brilliant. It's a lot better than nothing. I can't remember whether the Fidelity 2001 manual is better, which is the same innards. So we'll go to channel 20. And see whether we can get two. I'll try and get it on frequency first. Let's go over to the appropriate camera. You've got to be careful not to. Sometimes you think, oh, if only it'll just go a bit higher, and then the core breaks. So just watch that. I don't think it's going to go, but it's going to be. That's as high as it's going to go. So it's 112. So it's absolutely fine at that. if you start, you know, if you can't bring a radio up higher than 085, then you're going to have to take some kind of action. Now this is starting at 095 or something like that, wasn't it? So we brought it to 115. Otherwise we're going to start having to change the crystal, and trying to find one on our scrap chassis is now getting like hen's teeth. Having them custom made for £35 is out of the question, and buying them in from China in cheap batches, they never seem to work properly. So you buy a bag of 20 and you know you end up with finding one that is usable, and how long they're going to last is another question. So in a difficult situation with that. Right, so we're going to transmit tune-up. Let's go on to the other meter. Maximum. If you find that ballast resistor linked out or missing, you must put it back in, or you'll end up with it transmitting more on aircraft band than it does on 27 megs. I've done that demonstration before. Yeah, you get 7 watts out of the set, but only 2 of it's on 27 megs and the rest is on aircraft band. I may have to change the ballast resistor if I can't get it a bit nearer. My fail rate on this is going to be around 3.5 watts on this chassis. And it is actually doing 3.5. So let's see what they've got in there. Right, I'm going to unpower it. We'll swap that ballast resistor. So let's see what they've got in there. So you see, it's 2 watt resistor that. So they've got 2.2 ohms in, so we just need to pop that down a fraction and put a higher wattage in. I think we often put 1.8 in. I usually have a selection. Three, that doesn't help. .8, that's what we want. We've gone and discontinued these as well, so that's not going to help us much in the future. There will be an alternative, but it's a nice quality one, this. So we've got one piece of sleeving, so I'll recover that and we'll put that on the most vulnerable end. So this is like 6 watt rated. So if I put the insulated end where those other components are, I think that's the safest thing to do. I've put this in as far as I dare, but I just will trim the end off there, because we want it high up so that it's not breathing its hotness onto anything. Yes. Right, I'm going to put the lid back on underneath. Right, we'll power it back up. See what we've got now. 4 watts exactly. Absolutely on the button. Let's just make sure that's... Yep. There we go. Good. And with a 6-watt resistor, it's going to be more likely to be able to source enough power to do a 4-watt output, whereas a 2-watt resistor or a 3-watt resistor is going to get hot pretty quickly and the power's going to drop off. So there we go. That's I'm pleased about that. Straight up to 4 watts. So that obviously has a cost to it, and they're more than £1, those resistors. So we've put 1 R8 6 watts in. It's the only part we've fitted in this batch so far, so that's now 4 watts. That is now 79116. We'll do the deviation. Preset there. 1, 2. Well, helps if we're in the right mode. Wallow. So let's get our little oscillator. I've seen these set as stupidly high as 15, which is only going to be louder to somebody on a Fidelity 1000. Wallow. That's it. And I'm just going to check his mic, because there could be a difference. They look like the same type, but you never know. Wallow. It is. It's louder with that one in. So we'll set it up with this. Wallow. That's it. But we'll carry on everything else with our mic. So you know how the squelch is set wrongly on this, and the LA1230 was originally designed, Sanyo chip, originally designed for stereo hi-fi tuners, and it has a built-in squelch, which the idea is that it mutes between stations. So when you're tuning around between your radio stations on the dial, it will mute, so it squelches. And if it's not set up right, that will come in, and that's what's happening. Right, back to transmit. So we need to set this now for the fairy light. Just check it's all 4 for 4 watts. It's supposed to be 3.7 watts is your what you're aiming for, it says on these, but it was just struggling to do 3.5, and so I know they can do 4. Low power is preset. There's nothing we can do to alter that, but just for the record, and I will write that down because we're doing these low power tests now, it is 300 milliwatts. There we go. Yeah, we're doing this transmit meter. They want it to draw less than 1.6 amps. This is one of your tests. And it's 1.36, so that's well in. Your low power should be supposed to be between, they say, between 0.2 and 0.4 watt. Of course, the legal position is it's 0.4, but as far as they're concerned, if it's between 0.2 and 0.4, that's fine. And as I said, it's 0.3, so that's excellent. We don't need to do that. We're doing it through the test set. So how do we set? How do we set that? Our meter alignment. So we know it's RV1 and it's red LED number 5. Right. So in other words, the 4th LED, even though it says number 5. Well, how bizarre is that? So RV1 is there. So press transmit, and we're supposed to have all the red LEDs but not the green one. So just need to change that. There we go. And when we go to low power, it will probably be 1 LED. I don't need to do this, but we will do for a laugh. It is. Right, so that's that set. So that's the VCO done, the transmit done. That's it. Now we'll go on to receive, and that's now got a smooth volume control. So we're going to start by setting the detector like we usually do. So we want an S9 signal equivalent on the test set. So that's the 100 microvolts. Let's go over to that oscilloscope. It's a funny display. Anyway, we can still set it whatever it looks like. It goes a bit nasty when you put a bigger signal on. I think it's that one there. Just check. Such a dreadful write-up that so we're looking at that, but it's such a bad copy I can't see it. What's the redrawn one like? T11, isn't it? Yep. It is that one. Miles out. That's better. It still doesn't like a big signal though. But that'll probably be the IF that's out. I'm going to have to override this squelch control because it's still cutting in Squelch is it that one? No, it's that one. I'm just going to spray that just in case. That should have disabled the squelch controller. Right, so with the cyanide meter around 4 dB, remember this receiver is already really hot, 0.3 of a microvolt. We'll go through the front end. You know, we have gained a tiny bit. I've dropped the attenuator to 4 again. Right, good. We'll just increase the signal now and do the IF. I forgot to check whether we're on frequency. So we need to be tuning this at 116, don't we? 79116. It's that detector I just need to recheck. That's all right. Put a lower signal on for that. I think that's where we are. I don't think we're going to get anything better. So we've now, if I go back to the oscilloscope, I've now got a whacking great big signal on when I can find the oscilloscope. It does that. I don't know whether that's the way the instruments are thing, but it's so much cleaner than it was. So I think the IF was a little tiny bit out. We know the detector was. So let's read off what we've got. Let's put the cyanide meter back up. That's 0.3 of, I'll tell you what, before we do that, we're hearing 0.3 of a microvolt there. I'll put a different tone on. So it's that tone. I'm hearing that all the way down to 0.1 of a microvolt. So we'll go back to a 1 kilohertz, then we can read it on the cyanide meter. It's actually exactly the same, but it's unravelled now, so there we are. So that's nice and sensitive. That leaves the S meter. So we'll put S9 on, which is, and we're supposed to be having 4 lights lighting. So that's the preset there. So that's S9 at the right thing. We'll increase the signal on the signal generator and it comes up to plus 30. We'll reduce it and it drops down. So that's set. So now we need to fiddle with the squelch. Now the squelch is the letdown on this chassis. So I'm going to turn the squelch to full. I know I've fiddled with it, at least it's still coming in. That's 1 microvolt at full. We need more than that, but it needs to be such that it, when we unplug the aerial, it's still sat there hissing. That's 100 microvolts. So that's where I want it to be. So we're going to turn it down and see, when I turn the signal generator off to standby, where it comes in at. I think part of the problem was that was dirty. So let's go over to the attenuator. Set the squelch to threshold. So it's not hissing at the bottom end. I want it to hiss at the bottom end. So we do need to reduce it. Right, I'm going to unplug the aerial, switch it off, switch it back on again, and it squelches. Yeah, it's on the verge, but it does. The set does open up. Right. Set threshold. Switch the signal generator back on. So it's coming in at 0.3. It's leaving us at 0.2, so that's nice and sensitive. And the new max, because if you remember I've just altered it, is 30 microvolts for full. And that's the best balance I can achieve. And that is pretty normal on this type of chassis, that you've either got a strong squelch that never ever, that when you pull the aerial out, the radio doesn't sit there hissing. So it's that balancing act. So we're done. That's it. Right, we'll unplug it from the test equipment and we'll plug it into the Amstrad 99 roof aerial. One nano, Roger. If I put this on 31, it'll come over our tannoy and I'll hear the Roger bleep. Yep. Roger. Well, I can't hear anybody on there today, so it's 35 miles to our nearest city. And we often hear the burner brigade at Nottingham coming through. But there you are, it's about 6:30. So there should be time for us to do an on-the-air test for that. So there we are, an Amstrad 901 now doing 4 watts, and we'll see how it performs around Scratchy Corner. Thanks for watching.